Welcome to Math with Michelle, where math finally makes sense. Whether you're tackling high school math or diving into college algebra, I'm here to break it down step by step with real examples and zero stress. From algebra to functions, graphs to equations, I've got it covered. Hit that like button and let's master math together.
This video is just to help individuals who need a little more help with asymptotes and behaviors and things like that. So first of all, an asymptote is just an indication of what your end behavior is doing. So for example, if you have a graph like this, we are going to have a vertical and a horizontal asymptote. The vertical asymptote is going to be because of these two arrows right here, and the horizontal asymptote is going to be because of these two arrows right here. Okay. Whereas you might see some that might look like this. And in this case, we still have a vertical asymptote, but now instead of a horizontal asymptote, we have a slant asymptote, okay, also known as an oblique asymptote. So when it comes to vertical asymptotes, your vertical asymptotes are your domain errors, once you exclude any holes. Okay, so what do I mean by once you exclude any holes? So let's say you factored something and it's x plus 3, x plus 5 over x minus 2, x plus 5. So in our domain, we see our domain errors are at that x cannot be 2 and x cannot be negative 5. So x equals 2 is going to be a vertical asymptote, while x equals negative 5 is going to be a hole. And the reason for that is it's a removable discontinuity. I removed it. I canceled it out. So negative 5 didn't work in the original, but now that I've reduced this, it works. That's why it's a hole. So non-removable versus removable. And a lot of times you're not going to see the hole where you will see the asymptote. So let's go ahead and let's pop that fraction in here. And again, I'm going to do it in the unreduced version first. So x plus 3, x plus 5 was my numerator. And we had the quantity x minus 2 and quantity x plus 5 as my denominator. And I managed to put them all in the same thing. I thought I hit the down arrow. So x minus 2, x plus 5. Okay, so when I go into my table of values, I'm definitely seeing the error at 2, and I'm definitely seeing the error at negative 5. But when I graph it, I'm only seeing this one vertical asymptote. I have asymptote detection turned off. But something's going on there at negative 2, or sorry, negative 5, and I'm just not seeing it. So in my window, I'm going to go from negative 6 to negative 4, and go ahead and graph that. So you can't really see it yet, so now I'm going to go ahead and zoom in more. I'm going to go from 0 to 1. And you can just barely make out that little bitty blip. That's what's going on with the hole. So that's why it's called a hole. It's just a little bitty smidge blip on the radar. So your vertical asymptotes you will not cross, okay? Now, any other asymptotes, whether it be horizontal, slanted, parabolic, whatever, these are all found by taking your numerator divided by your denominator, and you'll get your quotient plus the remainder. You're going to kick that remainder out, and that's going to be your asymptote. You can cross these, but you just need to make sure you understand what's going on. So for example, let's go back and look at this here in its full view. This appears to flatline. Now we don't know whether it's at a fraction or not, okay? So I'm going to go ahead and I'm going to divide the original was x squared plus 8x plus 15 over x squared plus 3x minus 10. Okay, and if I do long division with that, if you don't know how to long divide, go back and watch my division video. X squared goes into x squared once. 3x minus 10, and we're going to subtract all that. 5x plus 25. Don't want to make that sign there. Because the degree of this is smaller than the degree of this, we are done. The remainder is 5x plus 25. But for the purpose of our asymptote, we're going to ignore our remainder. Y equals 1. And when we come in here, if I draw y equals 1, it should flatline at the same spot as our arrows, and we could even zoom out further. Negative 30 to 30, we'll go by 5s. That way we don't have a lot of dashes. So there's our original graph. And absolutely, that does definitely go well. Now, we can check, does our graph ever cross that? Well, the way that we would do that is we just set it equal. Multiply over. Subtract the x squared, we get 8x plus 15 equals 3x minus 10. Subtract the 5x, subtract the x equals negative 5. So yes, at negative 5, apparently we are going to be crossing it. We're not going to cross it very much. Oh, we would have crossed it. Why didn't we actually cross it at negative 5? That's where that hole was. So we don't actually cross it. It was a domain error. We couldn't actually utilize that number. So sometimes you'll find that out. So domain error, no, we do not cross. Could we have? Yes. Okay. And then you would draw that. You would draw the key features, you would have the hole, you would have the asymptotes, and you'd be very careful about it. I'm not worried about you being able to draw the graph. I'm worried about you understanding the points of the graph. So also, in this case, we had that vertical asymptote at 2, right? That was our vertical asymptote. As x got closer to 2, but it was on the left, our y's went down to a negative infinity. However, as x got closer to 2 from the right, our y's went closer to positive infinity. Now, our hole was at x equals negative 5, right? So, let's take this out. What happens as we approach negative 5, but we're slightly to the left of it? What does our y get closer to? Now, negative 5 obviously is blank, so negative 5.1. Well, that's at 21 over 71. Negative 5.001. 2001 over 7001. Negative 5. We'll get really close to 5. Okay. Well, I happen to notice that 2000, right? .2857. I noticed that 2000, 7000. See that 0.2857? So it's getting really close to 2/7. What about from the other side? What if I did negative 5 to the right? That would be like negative 4.9, right? 19 over 89. What about negative 4.99? That's roughly 200 over 700, right? Or roughly 2/7. Yeah. Now, how could I have gotten this 2/7 without needing to do this? Well, we had reduced it to x plus 3 over x minus 2. back. See how it would reduce? If we substituted -5 into the reduced version, when x equals -5, we get -5 plus 3, that's -2. -5 minus 2 is -7. Negative divided by negative is a positive. So here, that's the other clue that this is a whole, is that whether you're on the left side of -5 or the right side of -5, your y values are about the same. That's a clue that this is a whole, not an asymptote. And for a fun feature, if you've ever watched Mean Girls, this is an example of when the limit does exist. This is an example of when the limit does not exist, because the y's do not agree. The y's do agree. So that's the difference between the limit not existing and existing for your Mean Girls reference. Okay? I'm more curious, the idea behind this is a behavior of asymptotes. So let's go ahead and, like here, one y went up, one y went down. We're going to look at this graph first, and we're going to come back to y second with parts of it. Okay. Now this graph looks like kind of like a volcano or the old Atari symbol, right? Here they're both pointing up. It's not like before where one was up, one was down. Why are they both pointing the same direction? Well, when you factor this denominator, it's x minus 1 times x minus 1, or x minus 1 squared. That squared is the big hint. Because it's squared, the end behavior on each side of your asymptote of 1 is going to be even or match, because 2 is an even number. Okay, now was anyone able to calculate the horizontal asymptote without actually doing anything? Some of you might have already noticed that because these are both x squared, once you put it in for the first thing, everything else is going to be a remainder. So y equals 2 is going to be that horizontal asymptote. Okay, so that's kind of all I really wanted to talk to you about on that one. Our domain is everything except 1. Our range is y is greater than 2. I have two others that I really want to focus in on, and that's where the kind of bigger idea is going to come from, because I want to make sure you can understand how to get fractions and everything else that's going to come out of this. Taking a look at our next function, f of x equals 3x squared minus 2x minus 1 over the quantity 2x squared plus 3x minus 2. Okay, so the first thing is I could go ahead and get my horizontal asymptote. I could do my long division, where I have my 3x squared minus 2x minus 1, 2x squared plus 3x minus 2. This one's kind of tough because of the fraction, but I would have to multiply by 1.5. That would give me 3x squared plus 4.5x minus 3, and then I would subtract all that and have negative 6.5x plus 2, and we can see that's all remainder. So now we know our horizontal asymptote is at 1.5 or 3 over 2. And when we check, will this ever equal our horizontal asymptote? Cross product. 6x squared minus 4x minus 2 equals 6x squared plus 9x minus 6. The quadratic parts are going to cancel, so that's going to give us 13x here equals 4. So yes, it will cross our horizontal asymptote when x is 4/13. Now, if I re-look at this function in factored form, same function, just factored form. And then I'm going to point out the graph so we can see the relationship between everything. Okay, If I look at the zeros from the top, I get negative 1/3 or 1, and from the bottom I see 1/2 or negative 2. And we've already talked about the denominator is your vertical asymptotes or sometimes your wholes, but since they don't cross out, they're both vertical asymptotes. So let's see what's going on with our numerator here. So I have this graph including our horizontal asymptote, and I do see it crossing. And let's just double verify. We said at 4/13. Absolutely, it crossed at 4/13. At 4/13, our y value is 3/2. And we can see that 1/2 is that vertical asymptote here, and that negative 2 is also a vertical asymptote. And if I do calculate value for 1/2, it comes up blank because it's a domain error. Negative 2 also comes up blank because it's a domain error. But let's look what happens at negative 1/3. That's the x-intercept. And positive 1, also the x-intercept. So when we factor these were the vertical asymptotes, sometimes the wholes, always the domain errors, but these are the x-intercepts. Unless domain errors. And in that were the case, it would be a whole, right? So factoring the numerator and the denominator gives us a lot of information. It's that division of the two that gives us our asymptotes. Okay, so let's clear that out. And we're going to take x squared minus 4x minus 5 and x minus 3. Now just a reminder, the numerator factors to x minus 5, x plus 1, and the denominator doesn't factor. So from what we just learned, we should see a vertical asymptote at 3, an x-intercept of 5, and an x-intercept of negative 1. Oh, there it crossed at negative 1. There we had that vertical asymptote at 3, and it's crossing at 5, but what the heck is going on here, right? So we had x squared minus 4x minus 5 over x minus 3, or factoring it to x minus 5, x plus 1 over x minus 3. So we know 3 is the domain error, and so 3 is the vertical asymptote because it was not a whole. 5 and negative 1 are x-intercepts, and the best practice on those is actually to write them as 5, 0 and negative 1, 0. And we can see that. But this definitely does not have a horizontal asymptote. So this means that it has one of those oblique asymptotes. So we have to divide and ignore our remainder. I could use long division, but this one happens to be one eligible for synthetic division. So I'm going to use synthetic. If you don't know how to do that, go back and watch my video on synthetic division. I'm going to bring down a number, times add. That's my remainder, so that leaves me with y equals x minus 1. Okay, and to graph it faster, I'm going to come back into my format and I'm going to turn off my asymptote detection, so it will draw that vertical asymptote, but I'm okay with that. And we don't need this version now. X minus 1. So if you notice that red line, it is closing in on our arrows. And so therefore we are doing great. We happen to know that that definitely is where we're going with it. So make sure that you are always finding your asymptotes, even if they are not horizontal. The best way to find the non-horizontal ones are to divide and ignore the remainder.
Thanks for learning with me here on Math with Michelle. If this helped, give it a like and don't forget to subscribe for more clear and simple math lessons. Got a question or topic you want me to cover? And drop it in the comments. Until next time, keep practicing, stay curious, and remember, you've got this.